Hello and most welcome to 1246 of the series. We'll continue with Roberto Mangabeira, Unger, or how it's supposed to be pronounced in Brazilian Portuguese. We took off at a new kind of being appears, forming itself in a novel way and exhibiting unexpected regularities. The significance of this argument about the analogical application to cosmology of ways of thinking characteristic of natural history is not that the life and earth sciences serve as a model for cosmology. Much less than they hold the secret of solutions to the enigmas resulting from rejection of the two cosmological fallacies. And for repetition, that one single universe and that time is real. The point of the argument is rather that the problems cosmology confronts, once it rejects those fallacies and pursues unflinchingly the implications of its discovery that the universe has a history are not unique to its domain of inquiry. They reappear in other areas of science, in some of which their importance has long been recognized. So we continue here. And pursues unflinchingly the implication of its discovery that the universe has a history are not unique to its domain of inquiry. They reappear in other areas of science, in some of which their importance has long been recognized. It is not enough to say that cosmology is a historical science that can resort with benefit to some of the ideas and methods of natural history. The deep question presented is how the study of the universe can be both historical and a science. The conundrum of the meta-laws is simply the sharpest expression of this more general problem. Natural history provides only an imperfect model of the path toward a solution to this problem. It is an imperfect model because the scope of its inquiries is merely local. It is also imperfect because the generality and simplicity of its explanations remain limited for the reasons that the principle of the path dependence makes clear. The question of how cosmology can be both historical and a science remains unanswered. To answer it is one of the chief goals of this book. The argument and social and historical study. The problems addressed in this book have striking analogies across the whole field of social and historical study. Once we free ourselves from the superstitions that prompt us to see the study of society and history as weak biology and biology as weak physics, we are free to recognize these analogies and to learn from them. The idea is that everything changes. Laws and even symmetries and supposed constants, that the stable and recurrent relations that are causal explanations ordinarily invoke cannot be constant or eternal, but rather must co-evolve together with the states of affairs, that there may be causality without laws, and that more generally, not particularly, organization of reality lasts forever, may seem strange to those whose minds have been schooled in the traditions of physics. These ideas occur, however, inescapably to whoever engages the study of society and history. Puzzles related to those that are central to this cosmological argument have there long been evident. I will take a pause here at page 67 in the reading of the Mangabeira and try out a summary of the whole thesis. It's a tryout I was thinking of. It might help the understanding, and I'm quite certain it will not bring anything bad to the understanding, because it's a whopping 67 pages now. That's a lot. So we think we have a foundation strong enough so we will not fall into the trap of making a preemptive understanding, which I think could be devastating, but now can be avoided. Listen to this from Anaximander. All things originate from one another and vanish into another, according to necessity, in conformity with the order of time. All mysteries of physics come down to the nature of time. Time is the most pervasive aspect of everyday experience. Many physicists and philosophers believed that time is an illusion which must be transcended to perceive the real and true, that is, eternity and unchanging laws of physics and nature. Whatever is real is just real in a moment of time, being one in a succession of moments. The past was, but no longer is real. We can, however, interpret the past by find evidence of past processes in the present. The future does not yet exist, and thus it is open. We can, however, make predictions, yet the future may produce genuinely novel phenomena. Nothing transcends time. Not even the laws of nature. Which therefore can evolve over time. Time, is it elusive or is it real? Newton's classical framework. Nature consists of nothing but particles with unchanging properties, whose motions and interactions are determined by timeless laws. This framework is suited to describe parts, apple, planet, galaxy, of the world, but it fails when being applied to the universe as a whole. It is impossible to stay outside of the system studied when it is the entire universe. All major physical theories are about parts of the universe, and we leave our sense and the measurement tools outside of the system. Gottfried Wilhelm Leibniz's principle to frame science, the principle of sufficient reason, there must be a rational reason for every apparent choice made in the construction of a scientific theory, in particular of the universe. Leibniz's vision: everything is immersed in a network of relationships. Time must therefore be a consequence of change, governed by causality. Space and time are relational. Emergence is an important term in a relational world. Rocks are hard and water flows, but the atoms they are made of are neither solid nor wet. One falling. Gravity is the only fundamental force whose effects everyone observes with no need for special instruments. Already small kids struggle with gravity. Galileo not only discovered how objects fall, but also explained it. Falling objects on Earth trace a parabola, a simple curve that is the set of points equidistant from a point and a line. Galileo's observation that bodies fall along parabolas is one of the first examples we have of a law of nature. But what is mathematics about? And why does it come into physics? Even if curves and numbers resemble objects in nature, they are not the same as natural objects, which exist for a limited time span. Mathematical objects seem to exist in a separate, timeless realm of the ideas after Plato, perhaps. However, things and humans live bounded in time and in contact with other things, similarly bounded. This vision of transcendence via physics to the timeless is fatally flawed, related to its claim to explain the time bound by the timeless. Reality is time bound, mathematics descriptions are timeless. The disappearance of time, which is the second one. Ptolemy's epicycle framework Earth is at rest at the center of the universe. Planets move in epicycles, i.e. small cycles rotating with a 1-year period around points that move on bigger cycles around the Earth. Copernicus then put Earth as a planet and the Sun in the center. Finally, Kepler found that Mars traces an ellipse. Not a circle in space. Why do planets move in elliptical orbits? What compels them to move at all? Then to the next one, Newton himself. The force that impels everything on Earth to fall toward it is universal and acts also to pull the planets toward the Sun and the Moon toward the Earth. Gravity. All planetary motions are consequences of a single law of motion. Timeless mathematics was found at the heart of everything that moved. on earth and in the sky. 3. A game of catch. Motion is a change in position over time. But what is the position and what is time? Two answers that physicists have given. One, positions of an object is relative to a spatial landmark of some sort. This is from Einstein. Position is absolute in space, beyond its relation to something else. That is from Newton. Time. Time of an event is measured relative to another event by reading the dial of a clock. Time is absolute as perceived by God and hidden behind all change. Quote from Newton. The process of recording emotion, which takes place in time, results in a record which is frozen in time, a record that can be represented by a graph, also frozen in time. Some physicists see the graph as 1. Deep insights into the nature of reality is a mystic. 2. A useful mathematical tool. And if you want to graph a through as a curve, it will be a curve in space-time, so-called Einsteinian space-time. Confusing space-time with reality means committing the fallacy of spatialization of time. 4. doing physics in a box. Most what we know about nature comes from experiments in which we artificially isolate a phenomenon from the rest of the universe. The method of restricting attention to a small part of the world has enabled the success of physics from the time of Galileo and Newton. We call it doing physics in a box. To apply mathematics to a physical system, we have to separate it from the complexity of motions that is the real world. Thereby, we try to decrease, but can never fully eliminate the outside influences on our system. Part of its definition is a list of all variables which make up an abstraction. We call it the configuration of the system, phase space. It determines everything we want to know or can know at a moment of time. Newtonian paradigm. What one what are the possible configurations of the system? What are the forces that the system is subject to? This is based on the assumption that the configuration and the law's forces are timeless. It's well worth repeating. This is based on the assumption that the configuration and the laws are timeless. Nota bene. Five, expulsion of novelty and surprise. Laplace once claimed that if we were given the precise position and motions of all atoms in the universe, together with the precise description of the forces that we are subject to, he could predict the future of the universe with total accuracy. This claim today includes the standard model of elementary particle physics. Containing all we know of nature. 1. The future is completely determined by the present. 2. But as you seek the reasons for things to be as they are, and not otherwise, you are driven deeper and deeper into the past, and to consider even larger systems. 3. The argument for determinism is thus a question about cosmology. 4. Is there any space for novelty and surprise? 2 other things. Can our theories be scaled up to theories of the complete universe? And the second is, do initial conditions really determine everything? Non-linear theory tells us that small changes in initial conditions are amplified exponentially to very big changes in outcome. A flap of a butterfly's wing can influence the weather oceans away and months later. The very time reversibility of the laws of physics removes time from the conception of nature. 6. Relativity and timelessness. 1. Einstein assumed in 1905 that the speed of light is universal. Nothing can travel faster than light in vacuum, and everybody measures that same speed. And he utilized a strategy he called operationalism. The only meaningful way to define time is to stipulate how to measure it. You must describe what a clock is and how it works. Observers in motion with respect to each other will reach different conclusions about whether two events are simultaneous or not when those events are distant from each other. Two fundamental concepts stem from special relativity. Relativity of simultaneity, big blow to the notion that time is real. Two, block universe. Pictured as a system of events connected by causal relations. The principle of relativity holds that speed, other than speed of light, is a purely relative quantity. There is no way to tell who moves and who is at rest. The block universe describes the whole history of the universe as a mathematical object which is timeless. It marries space and time in the 4D Minkowski space-time. H. Minkowski, mathematician, quote, henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. And this is from H. Weil, mathematician. The objective world simply is. It does not happen only to the gaze of my consciousness crawling upward along the world line of my body. Thus a section of the world come to life as a fleeting image in space which continues its changes in time. But this is coming from J.R. Lucas. The block universe gives a deeply inadequate view of time. It fails to account for the passage of time, the preeminence of the present, the directedness of time, and the difference between the future and the past. Special relativity cannot be applied to the whole universe because it does not contain gravity. Relativity and timelessness. General relativity, Einstein 1915, is based on the simplest of all scientific ideas. Which is that falling is a natural state. All bodies fall with the same acceleration. Regardless of their mass or any other properties. Equivalence principle. When you fall freely, you can not feel your motion. Three things comes from this. Heavy and inertial masses are equal. Two, gravity is equivalent to acceleration. Three, in a local inertial system, special relativity applies. In general relativity, space-time is not Euclidic, but gravity determines the metric of space-time. Quantum cosmology and the end of time. Many of us think the purpose of science is to describe how nature really is, to give a picture of the world that we can see. and we can believe to be true, even if we were not there to see it. Quote from Niels Bohr: the purpose of the scientific theory is not to describe nature, but only to give us rules for the manipulating objects in the world and a language we can use to communicate the results. I continue there. I got here. Well, it's a sort of summary. I hope it's helpful. It will expand a little what you heard previously in the 67 pages I read from the book, A Single Universe. This is a sort of the most important points and remembrances from the book. Could help. I don't think it would be trouble though to give it to you. Okay, I say thank you very much and have a very pleasant afternoon. Bye bye.